Welcome everybody to the second edition of the Oil Tech Talk Live with NORA. And tonight, in addition to myself, Bob O'Brien with NORA and Alan Mercurio of Oil Tech Talk, everyone's friend in the industry, we're pleased to have Scotty Nicholas, who's the regional manager at Thermo Products, I guess better known as Thermo Prod. Major furnace manufacturer, major oil furnace manufacturer. Really happy to have Scott here tonight.
Thank you for having me here today.
You're a kid. You're very young.
Yeah.
How did you get where you are at a relatively young age? Had you started the industry? What drew you to it? Just how'd you get here?
So really how I ended up in this trade, because honestly, HVAC wasn't my original plan when I graduated high school. Back in 2005, I graduated high school, went to a community college looking to study criminal justice, wanted to be a police officer, a correctional officer. And one night I was studying at home at my parents' house, and their Thermo Pride oil furnace had no heat. So, of course, I was upset trying to study while freezing my butt off. The whole time thinking, oh man, I wish I could just fix this issue and then get back to studying and being nice and warm. Obviously, I had no idea what I was doing. So a technician came in, fixed the issue. And then within a couple months, I was enrolled in the HVAC program at Porter and Chester in Chicopee. So I guess a full circle moment here. The company I'm currently working for, Thermo Products, actually got me into the trade because there's an issue with the furnace 18 years ago. So pretty fun to work for Thermo Products now, but obviously I didn't start right at Thermo Products. At school, Porter and Chester, by the last term, I found a job at Rice Oil and Propane in Greenfield, Mass. Worked there for about 11 months, got laid off, actually started painting for a local contractor, and actually thought for a moment I was never going to get back into the HVAC industry. But while working for that painter, I actually, he was getting a boiler installed, a Badaris in his house, and the owner of Cerner Heating showed up, Bruce Montague, if he's listening. Hi, Bruce. But he actually showed up on the job site to help get the boiler in the basement, and he talked to me, gave me some words of encouragement to get back into the field. And within a month or two, I was working at Cerner Heating and spent 4 years as a technician doing installs, doing service, doing maintenance. And in those 4 years, I knew deep down I wanted to do something a little bit bigger. And of course, the on-call life, I wasn't a big fan of that. I'm sure a lot of people watching this video think the same thing. On-call can just go away and not deal with it. But I knew I didn't really want to do that. So I ended up finding a job posting at Carlin Combustion. They were looking for a tech guy. So I ended up at Carlin Combustion doing tech support and doing trainings. And as a young person at that time, 26 years old, 27, trying to start a family on the road is very tough. So I made the decision to go back to Cerner and do equipment sales. And after about a few months there, I met my current boss, Rob Hackett, and here I am.
That's too. Yours is a great story because it illustrates that there's not just one path. You can meander around other things, and people, maybe they don't like it in the field, but there's other paths with manufacturers reps and manufacturers themselves and tech support and teaching in trade schools. There's a lot of different ways you can go in this industry. Obviously we need people in the field. It's the most important. Guys in the trenches. And a lot of people, when they make these moves, they're actually involved pay cuts. A good technician will probably make more than a lot of these roles, at least initially. Yeah. So, but I think it's important for young people to realize, and even not just young people, career changers. Yeah. People who've been, they've been obsoleted or laid off, they're in their 20s, 30s, 40s, 50s. That there's a lot of potential in this industry. So much for that. Let's dig into the actual what we came to discuss.
Yeah, let's jump into the good stuff.
Which would be airflow, and more airflow.
Absolutely. So
why is airflow so important?
Being a younger salesperson when I first started with Thermo Products, it was always intimidating to start talking technical because there's a lot when it comes to oil furnaces, right? You got the airflow, you got burner, you got ductwork, you have all these different pieces. And when I got asked to do a technical training last year, for one of our local distributors, I thought about it for a second. I'm like, all right, obviously, I don't want to do just the product training, and I could do the typical service, installation, and maintenance training that I do that is just very broad, do's and don'ts of installs. Like don't put a furnace on top of a pallet and think it's going to stay there for 30 years. But when it comes to an oil furnace, what's the most important thing? So I sat there thinking about that. And then I go back to the first day I was at Porter and Chester, 17 years ago or so. First day in class, my instructor, he sat us down, and it wasn't just for oil furnaces, it's for HVAC in general. He asked the class, what are the three most important aspects what are the most three important things in HVAC? We all had these crazy answers: wiring, electricity. Can't remember all of them. But he's like, guys, stop. You're overlooking the most important thing: airflow, airflow, airflow. So it just dawned on me when I was trying to get this presentation together that yes, in the presentation I had for installation, service, maintenance, we did talk about airflow, but it was maybe for 10 minutes, if that. There's other important things when it comes to oil furnaces, but when it comes to doing these airflow trainings, if I can get it in people's heads to think about airflow 1, 2, 3, 4, 5, like top 5 on their list, then I think I'm doing my job, because I think airflow is probably one of the most common issues we run into that we like to sweep under the rug.
What's the common problems you see with airflow? Too much, not a little? How do you measure airflow?
So great question. So we got to remember, airflow drives everything in a furnace: heat exchanger life, efficiency, and safety. If you don't have proper airflow, your heat exchanger is going to overheat, your energy efficiency is going to drop, and in some cases, it's going to affect combustion. So one of the quickest ways to check your airflow is the temperature rise across the heat exchanger. So for most oil furnaces, the manufacturers will actually list the spec. So if you look at Thermo Products, you look at Spirit, Thermal Pride, Eco Plus, in our spec guide, we tell you exactly what the design temp rise is for that furnace. So majority of our furnaces, you'll see a 70-degree temp rise. Now, if you look in our instruction manuals, we'll say we want the temp rise anywhere between 50 and 80 degrees. And across the industry, across furnace manufacturers, especially oil furnace manufacturers, you'll see that 50 to 80 degree range. Now, if the temp rise is higher than that, it usually means that the blower's not moving enough air, or if it's lower, then you could be bypassing the heat exchanger, or the blower's running too fast. So it's important to get that temp rise, but that's not the only way that you can pinpoint what exactly is wrong that's causing the airflow issues. So temperature rise tells you what's happening in the air, but it doesn't tell you why. So that's where static pressure comes into play. So measuring static pressure lets you see how hard the blower is actually working against that duct system. So say you have high static pressure, that means your ducts are too restrictive, your filters are clogged, or registers are blocked. Or low static, that could indicate that there's leaks, or the air is bypassing that heat exchanger. So just measuring the temperature rise without the static pressure, I like to give this analogy. It's more of checking your car's speed, but ignoring whether the brakes are dragging. If you're just looking at the temperature rise, it's not going to give you that full picture. So we want to make sure that if you're ever running into any airflow issues, or even on any service call or maintenance call or especially installation, take 2 minutes, check your temp rise, check your static pressure, because that's going to save some headaches down the road for you.
How do you check temperature rise? Where you got to drill some holes in the ductwork in the case of the furnace? Where do you drill the holes, and what exactly are you looking for?
Yeah, so when you're looking for temp rise, you're looking at the supply temp, and then you're looking at the return temp. Everyone likes to have a conversation and argue where the best spot is, right above, like a couple inches above where the furnace ends, and then you got your supply plenum on top, just a couple inches above there, above the because you got to remember, you get about 3 inches before you actually get to the top of the furnace from your heat exchanger to the top of the furnace. So a couple inches above the ductwork, that duct plenum, just drill a hole in, get your temperature. So,
I'm sorry, Scott. What if you have an A coil on it?
A coil, then you want to go above the A.
Go above the A coil.
Yep, go above the A coil, because if you go below that A coil, that's a restriction right there. So you're not actually getting your true temp rise if you go below that A coil. Now on the other side, on the return side, depending on high boil,
whatever you got.
You want to go before the filter, because what you're essentially doing when you're checking the temp rise, you're checking to make sure. Sorry about that. So temp rise, you want it a little bit higher. Sorry. Static pressure, you want it right above the furnace. Sorry about that, guys. I'm sure someone spot checked me on Facebook, but sorry. But anyways,
somebody's fact checking, right?
Yeah. So essentially what you're doing is you're trying to find the temperature differential between the supply and return. And so realistically, you're going to see the supply somewhere around that 140 range. If your airflow's good, you should be around that 140 range when you take your supply temp, if you have 70-degree return air coming back. So obviously it all depends on your return air. And now say the temp rise is too high, then you can start to, all right, we need to look a little bit more deeper. That's where we can come in and check our static pressure.
How do you do that now? So you use a differential manometer?
So you can use it with just a standard manometer. So the only thing you want to do if you do have a standard manometer, you want to make sure you have a static probe. So what the static probe, I'm sure everyone has seen one, whether or not they knew what it was. So the static probe, it's actually a probe that has a little 90-degree on it. So essentially what that's doing is, say if you just took your standard probe and just shoved it into the ductwork, what's that going to do? The velocity of that air is going to be just banging into your manometer. That's not actually checking to see what your static pressure is. That's actually seeing the velocity. So we want to make sure when you have that 90 in there, it's actually seeing the pressure that the air is working against for that duct system. So making sure you have that probe, that static probe, is essential. Now, if you don't have that probe, say you don't have a manometer, there's other ways to be able to figure out your static pressure and your temp rise. So if you look in every single one of Thermo Products manuals, Spirits manuals, our spec sheets will tell you the truth about the airflow. So like I said, every one of our manuals, all our spec sheets publish the tables connecting static pressure, CFM, motor amps, and temp rise. So if you guys go and look go to thermopride.com, pull up one of our spec sheets, pull up one of our instruction manuals. You look at the back of that page, and it's going to tell you, it's going to give you those tables. So, okay, the tables, that's perfect. I see everything on these tables. Well, what's that mean? How do I figure out what's what? You take an amp draw of your motor. Once you get an amp draw of your blower motor, you can use that chart to know how much air you're actually moving. So you pair that with your temporize, and you've got everything you need to decide if airflow is right or wrong. Uh, Realistically, working on a Thermopride Spirit Eco Plus, you could get away with not using a manometer. As long as you have something to measure temperature, you're going to be golden. You're going to be able to figure out everything just by the specs and the instruction manual that we have.
And back into it.
Yep.
The temp range, how would you adjust that? Let's say it's the temp rise is high, the temp rise is low. How do you know what's causing it, and what do you do to fix that?
So that's the great thing with checking your static pressure, because again, going back to checking your temp rise, checking your static pressure, temp rise is going to tell you there's an issue. Now the static pressure is going to tell you where you should look. So say you have high static pressure, that's telling you, okay, we have a blockage somewhere. We have
Dirty filter or something like that,
a dirty filter, something along that lines. So okay, we should probably look at the ductwork, even with low airflow. Low static pressure. It's most likely something to do with the duct system. Now, say your static pressure is fine, and the customer is still complaining to you about comfort or just something that sounds like airflow. Then you can start looking back at the furnace, at the board, at the motor. Then you can see, okay, well, maybe I need to make that change on the blower speed. But you don't want to just go like say it's our variable speed ECM or constant volume ECM motor. You don't want to just go flipping dip switches without knowing your static pressure, because you could change that fan speed and nothing's going to happen because you have so much static pressure that nothing changes. So just finding that static pressure is going to help point you in the right direction of what to look for or where to look.
Great. Excellent advice. Since you mentioned ECM motors, a lot of guys feel that the ECM motors will solve all these problems. That, if there's a restriction, it's going to ramp up and move more air. If there's too much, it's going to slow down. How do they know the static pressure against them, and how do they do that? And is in fact that true? Will they solve those problems?
No. So I used to believe that as well. And some of us were in the industry before ECM motors. Some of us were in the industry when they first got launched. Some of us came into the industry after they were launched.
In the belt days.
And then we're told some stories about the magic of ECM motors, and it's going to fix all your ductwork issues. That's not.
I heard those.
Yeah, we all have, and it's a great story to fall back to and make you feel okay inside. But realistically, it's just a Band-Aid. If the ECM motor, putting that on a poor duct design, yeah, it might work for some time, but probably in a couple of years you're going to be paying for $1,000 new ECM motor because it's just been overworking. So that's a very common misconception that in these conversations, in these trainings, I try to bring up, like, hey, the ECM motor is not magic. It will help some situations a little bit, but what's going to help the whole situation is properly designed ductwork. Because so if we break down the common issues, I mean, high temperature rise are usually dirty filters, undersized ductwork, or the blower moving so slow. So you put in a new furnace with a constant volume ECM motor. You walk in there telling the homeowner, hey, this is going to fix all your AC issues, all your poor airflow issues. The ECM motor is going to ramp up and it's going to overcome that static pressure for you. So, yeah, it can, but not without a cost. So I just mentioned constant volume ECMs, but we all have to remember there's two different kinds of ECM motors. So we have our constant torque ECM motors. So the constant torque ECM motors, they're designed to maintain that torque. If you want to talk torque, they're effort. So it's given the constant effort for that motor to keep spinning. So that effort is going to stay continuous no matter what it's working against the duct system. So as static pressure increases, that motor is going to try to hold that torque, but the airflow is still going to fall off. So if the duct system is undersized or the filter is restrictive, that airflow is going to drop significantly, even though that motor is still working hard. And that's why you see the high temperature rise and limit trips if the ducts are wrong, even with the ECM motor. Now, you heard me say constant volume. We used to say variable speed all the time, and that's another issue.
Those are the X13 motors.
So the X13 are actually the constant torque.
Torque, yeah.
Yeah. So the constant volume, variable speed, whatever you want to call them, those motors are the ones that are maintained to set the airflow. So those motors, they'll ramp up speed and wattage to overcome the high static pressure and try to deliver the program airflow. So again, your question was, will that help solve poor ductwork? No. I mean, it sounds like it should, but it comes with a cost. So you're going to be using more energy. It's going to be noisier, and it's going to stress the motor because of that excessive static. And then plus, I mean, you can't, once static is too high, you just can't push the air anymore. It comes to a point where your motor's just going to say, screw it, I'm done, throw its hands up, and then that's when we come in and say, well, you got to change your ductwork there, bud.
You see a lot of ECM motors returned for warranty. They were in fact good.
No, actually, not terrible. Not for warranty. Phone calls. I'll get a phone call probably a couple times a season. Just swearing at the ECM motor, and of course it's on the coldest day of the year. So it's like, what do we do now? Now being through distribution, it's not that big of an issue anymore because a lot of the distributors are carrying the motors for us now. But back when we were dealer direct, try saying, hey, we can't get you a motor for 1 to 2 days from North Carolina. That was a little tough to hear. But again, we don't see too many of them failing. But if anyone sees a constant volume ECM motor fail, go back and check that airflow.
It all leads back to that. It's basically like anything in the entire industry is that you have to be testing and not guessing. If you're not measuring temperature rise and checking
exactly
the temperature, you're flying blind. It's like trying to adjust the burner without a combustion analyzer.
Yeah. I mean,
pump pressure without a gauge, you're nowhere. Yeah. You need that information to even have a solid foundation to begin troubleshooting on.
Yeah.
So you recommend checking on every call, or just when airflow is an issue? When should it be done on an install? Right after a new install?
I think on every install it should be done. And again, this is coming from someone that has installed furnaces and has worked for companies that I understand sometimes time is a issue. But On the flip side, yes, having enough time to do everything again, checking your temp rise, checking your stack pressure shouldn't take more than 10 minutes. If it takes more than 10 minutes, there's another issue going on. So checking those, I think it should be done while you're checking the combustion test. But again, there's issues with some technicians doing installs and not using a combustion analyzer. So it's tough for me to say, hey, you should do it on every install when sometimes we can't get a technician to do a combustion test on every install. I can say till I'm blue in the face, but just sometimes it for whatever reason it doesn't happen. Then we end up going back and finding, hey, there's no test hole in the flue pipe. Let's set this up correctly first, and then see if the issue persists. So
I've seen it myself too. I think it's more management driven than the technicians themselves just being lazy or trying to avoid it. Alan, have you seen the same thing? You work more techs than anybody probably. So just
I think I'd say it's a mix of that, Bob. If we could, if you guys wouldn't mind, if this is a good spot to just ask a question, because we have had questions coming from the comments.
I'm sorry.
And Paul McGee's question is, can you speak a little about the importance of sufficient combustion air for installing new equipment? In his years, he found the vast majority of homes did not have enough combustion air available.
When it comes to combustion air, of course, that's more the burner, but of course the burner's on the furnace. So I would love to see combustion air installed on every single job. That's a wishful thought. I know it's not going to happen. One, it adds cost. So I know that's just a far-fetched dream. But when you look at the houses, when you look at all these weatherization agencies that are going around and making houses more efficient and making sure you're not losing enough heat, a lot of times what they're doing is closing that house up too tight and not caring about, hey, we need some fresh air in, not only for your furnace and burner, but for your dryer, for your water heater, for your stove range, for your kitchen fan. There's so many things that are using fresh air in your house that why even chance not bringing combustion air to that furnace right off the bat? Because that furnace could run great for 12 years, no issues at all. They get it cleaned every single year. And then year 12, Mass Save comes in and says, hey, we'll make sure no heat can leave this house at all. Your house will be the most efficient house on the block. Sign me up. 0% loans to get my house well insulated. And then year 13 comes around of that furnace. Technician opens it up. It's completely black inside, full of the sticky, wet soot. And the tech's scratching his head. What changed? Well, let's look back. What happened? Mass Save came in. Nothing against making your house efficient, but we have to make sure we're looking at the house as a whole, not just, oh, well, this is going to save you on your heating bills. But we forgot to mention you need to bring fresh air into your burner now as well. So it's obviously very important. We actually, in every single one of our instruction manuals, we tell you how important fresh air is. We give you the calculations to do. So we tell you, hey, if it's confined space, you need to bring fresh air in. And this is another thing that gets brought up all the time is I don't think we look close enough at basements when we're doing the square footage to see if we're in a confined space or not. Because think about some of the basements you've been in. I can name a few basements that I wish I could forget. You have those basements, you walk in, beautiful house outside, but then you go walk in the basement. From floor to ceiling, what do you have? Totes. And you only have one path to that furnace. So you could have the biggest basement in the world, but you could have that basement full of those totes. What are the totes doing? Totes are taking up the air, right? So you could have a 6,000 square foot basement, but filled with totes. Do you have enough combustion air at that point? No, you don't. So, Paul, great question. And I would love to see more fresh air put in, but I don't think we're going to get anywhere near that anytime soon.
Yeah, that is a great question, Paul. And if you look at NFPA 31 and do the calculation, 95% of the existing sites are going to be considered a confined space.
Yeah.
And a great point, Scott, with when you can figure the cubic volume to determine the space, you have to take out all the junk that's in it.
Yeah.
And yeah. Everybody's been in those spots where the basement's big enough, but it's 3/4 full.
But what else?
There's nowhere where those cardboard boxes are.
Yeah. What else? What else do you have down there, though? I mean, you could take away all of the totes. You have a dryer down there.
The more that dryer pull more air now too.
Yeah. So you have all. And what happens if? I mean, there's some houses that they leave their basement open. They got a finished basement, so they leave the door open at the top of the stairs. And what happens when that door gets closed? You could be cutting off that fresh air.
Yeah, no, you're right. And I mean, this has been code for years. It's been an NFPA 31 for years, and it's probably the most ignored part of it, because I mean, it's hard to figure out. You have to do some math. You have to take some measurements and do the math, and people aren't fond of that. But that was a great question.
Thanks, Paul.
Any more questions, Alan?
Actually,
we about combustion air.
Yeah, no, that's the only one so far. A few nods of agreement about having the issue with combustion air.
Yeah, that's a big one.
Yeah. And even to the point where on some of our furnaces on the mobile home, on the OME, we have a tag on the mobile home furnace saying combustion air needs to be hooked up, especially on mobile home furnaces. That combustion air is crucial, because you look at how tight everything is in a mobile home, and you see where you're drawing that return air in from. Everything's so compact that if you don't have that fresh air hooked up, you could have all sorts of odor issues. I'll give you a prime example. 2 days before Christmas, luckily it was nearby my house. It wasn't too far away. A great contractor in my area. They installed a OEM furnace, and it had been installed for a couple of years. This was actually my second time at the house. I don't like going for a second time. If I can't figure out the first time, if I'm back there for a second time, I'm not in a good mood to begin with, because one, I feel like I should have figured it out on the first job. First time I was out on the job. So what happened was I walked back in, and we thought we had solved the issue. We thought we had. There's some cross-contamination happening with the AC unit, but that ended up not being the case. It popped back up, so I was back out there right before Christmas. And the one place we didn't look for this job was underneath the mobile home. Not my favorite place in the world to be, especially a couple days before Christmas, crawling underneath the mobile home. So I talked to the technician. I'm like, hey, you know what? We've looked at everything in this house. We looked up and down everywhere. Something else is going on. We need to get underneath the mobile home. And he's like, you sure about that? Sales rep? I don't think sales reps like to go underneath mobile homes. I'm like, well, if we don't go underneath the mobile home, I'm going to be back out here next week during my son's birthday. We don't need that. So let's get this figured out now. So I go crawling underneath the mobile home, he gave me the longest direction possible to get to underneath the mobile home, where he went to the other side of the mobile home and got there in half the time I did. But I got right underneath where I thought the furnace should have been. And I'm looking up, I see ductwork, but I don't see the fresh air hole for the furnace, or nothing, no ductwork, no fresh air pipe, nothing. So I'm looking up, I'm like, it should be right here, right where this ductwork is for the self-contained AC unit outside. So I shoved my hand up, and guess what? There's a 6 by 6 inch opening above where the ductwork was, where they were pulling fresh air from. So that furnace was going into a vacuum. So what was happening was, when it was going into a vacuum, then it was trying to pull air from everywhere else. Guess where it's pulling from? The roof jack. So it was sucking fumes down back from the roof jack, because they weren't pulling fresh air. Well, they were, but they only had a 6 by 6 inch hole. Obviously, that's going to get used up very quickly. So that it just took going underneath the mobile home to solve that issue.
Sometimes they're not easy.
Yeah, but I gotta say, it was the cleanest crawl space I've ever been in.
I've been in a few, and I hope to never be in another one. But yeah, mobile homes have been a hot topic lately. Thermo Products' position on biofuels. New York State just went to a B10 mandate, and Connecticut's now B10. Rhode Island's B20. Mm-hmm. What are you guys' furnaces rated for? Are there any plans to up those ratings?
So right now, our furnaces are rated for B20, and that came after both Beckett and Carlin came out with their B20 ready burners. So going forward, we're still at B20, but we are testing B100 in the lab right now. So obviously, oil is a big part of our company. Obviously, we're one of the biggest oil furnace manufacturers. So making sure we stay on top of biofuel and the future is top priority for us, because if we don't follow along, where do we stand if we don't keep going along with B20, B50, B100?
Great, good to hear.
So hopefully, as things progress, we'll be making announcements, but nothing at the moment. But we are doing testing.
Okay, you ready for another question?
Absolutely.
Okay, so Shane Wells he'd like to know, would installing an ERV or HRV be something we should be talking to the homeowners about to fix the lack of air exchange in the house? I like that one.
Absolutely. That should be a conversation. Doesn't necessarily do anything specifically on the furnace, but having that conversation with homeowners. While Dave Westerfield, he's a past VP of OESP, and we've had a lot of different conversations over the years that I've known him. And one thing he told me that has really stuck with me is the time of technicians going into a house and just looking at the furnace or looking at the boiler is gone. As technicians, as salespeople, anyone to do with the heating, air conditioning industry, we should be going in looking at the whole house. Because if we're not looking at the whole house, eventually an issue with this part of the house will make its way back down to the furnace or boiler, especially when it comes to air exchange. So having that conversation early on, especially if it's a new customer, especially if you see there's a potential for some of these issues, then yes, 100%, we should be having the conversation with homeowners.
My experience has been a tough sell. They're not cheap. They're great, but they're not, it's a little more palatable to go to just bring, combustion, whether a fan in a can or an outside air intake during
Right.
burn, whatever way you can solve the problem. But
so I agree with you on that part, but as a technician looking at the grand scheme of the house, yes, you could bring in that fresh air to the furnace and the boiler, but also just being someone that, for the customer, letting them know that I'm thinking of them. Because think about some of these houses that get so tight that the furnace is starving for air. What else is happening in that house?
Oh yeah, the air quality is horrible.
The air quality, I mean, you need some fresh air exchange in here because you're not getting enough fresh air in here. And then they'll probably send you a nice fruit basket saying, thank you, we're not sick all winter anymore.
Yeah, that's a good point about looking at the entire house. Is the house is a system. It's not the combination of parts thrown together. They work together.
Yeah.
You think about a dryer having an effect on a furnace, or a dryer having an effect on anything, or the kitchen, the range hood or the bathroom fans, and all these things work in concert.
Just make sure we're looking at airflow a little bit more.
Yeah. On the air conditioning side, the same thing. It's crucial.
Oh yeah, AC
more crucial. Yeah. It's a really important skill to have.
Yeah, airflow. Without airflow, AC wouldn't exist.
It's how we're moving the energy by air, and air is not compared to water. Air is a less efficient transfer mechanism.
Yeah,
so it's more important than how you're moving it. It's rare you run into that on the water side of it, on the wet side of it.
Mm-hmm.
Yeah. So a really nice word here from Dave Westerfield. So a great comment he makes here, though, that I think we should share with everyone. He says, we need to pick up where Ralph Adams left off. We need to stress and teach proper duct sizing. It's a must nowadays. Amen, Dave Westerfield.
Yeah, absolutely.
Thank you, Dave.
Yep, Ralph was one of a kind. He's sorely missed.
Yeah.
And he was certainly passionate about airflow.
Yeah.
More so than anybody. And Scott also is now the executive vice president of OESP, and he actually took Dave Westerfield's spot when he stepped down.
Yeah.
Feel free to reach me out on any social media between LinkedIn, Facebook, social, Instagram. Trying to think if there's any others. Man, once you turn 38, you just start forgetting stuff.
Just wait. It doesn't get better.
But appreciate the time, guys. Thank you again.
Yep. Everybody here, looking forward to next month with John Dunleavy and Carlin Hydro Level. And thanks, Scott, for being here. It was fantastic.